Work done in a cyclic process. A system consisting of a fluid is subjected to a quasi-static process which can be described by a curve showing successive values of the volume V and corresponding mean pressure P bar of the fluid. The process is such that at its end the system is in the same macro state as it was at the beginning. It's called a cyclic process. The curve describing the process is closed, and as shown in the figure, show that the work done on the system in this process is given by the area contained within this closed curve. Okay, so I call this point, so let me concentrate on this curve. I call this point A and this point B in the cyclic process. And so if I calculate the work done in performing the cyclic process, the work done for a quasi-static process will be given by minus V initial to V final P bar dV. So I can think of the process as the work done in going from A to B following the upper curve. So I can do it along this path. So this is going from A to B along this path, and then I can return on the red curve from A to B. So this is going back, and this is going forward to point B. So I can see that the work done from point A to point B is minus integral A to B P bar dV. This is along this path from A to B, the delta V value is basically negative. So the work will come out to be positive in this case. And if you follow actually your right hand, you can see that the right hand rule shows you your thumb pointing away from the paper towards you. So that's the positive direction. So this is following the right hand rule. It is the area under this curve gives you the work done on the system from A to B. It is the area under this curve basically gives us W from A to B as absolute value. Okay, so WA to B is the absolute value. This is the area under the blue curve, and it's the positive. The work done A to B is positive, and also basically it's the counterclockwise direction. Right hand rule gives us a positive value, positive work done on the system. Okay, and how about the work done from B to A? Going back from B to A, we have again minus the integral from B to A P bar dV. Here this is the lower curve, and here delta V is positive, so P bar times delta V will be positive, so the work done will be negative. So WB A will be negative. So this is basically the minus, so therefore this is minus the area under the red curve. So the area under the red curve is here. So minus WB to A, so that's what it will give us, the area under the red curve. So therefore I find that the total work done from A to B plus work done from B to A is area under blue curve minus area under red curve. So this is equal to the total area enclosed. So if I subtract from the area under the blue curve the area under the red curve, then I'm left with this area, which is W net work done on the system in performing this cyclic process. Okay, so let's look at this one more time. We have a quasi-static process, which is a cyclic process. The end point and the beginning point is the same. So we start with A and end with A. So this is A, B, A. And I'm looking at the process from A to B, and I call this the blue. And then I'm looking at B to A, I call this the red curve. And I'm trying to calculate the work done on the system. Going from A to B, minus integral A to B P bar dV, because dV is negative, it will come out to be positive. So it will be the area under the blue curve so that will give me W A to B. Also, you can notice that using your right hand rule, this is a counterclockwise rotation, and your thumb points out of the paper, which is telling you it's a positive work done on the system. And W from B to A, on the other hand, minus integral B to A P bar dV, delta V is positive, so the work is negative, so it is minus the area under the red curve. So the net work is plus the area under the blue curve minus the area under the red curve. Why minus? Once again, you can see that going from B to A, we have an increase in the volume. So you would have a negative work done on the system. Well, if you follow the whole path with your right hand rule from A to B and B to A, you can see that the total area that I'm drawing with this closed curve is following a counterclockwise orientation at the boundary, so the net work done will be positive. So this is also telling me net work done will be positive. Okay, so I subtract the work done. I subtract the area under the lower curve from the upper curve. I find the total area enclosed, and that is the net work done on the system in the overall cyclic process.